Good afternoon, everyone, and thank you for joining us today on the Big Data Pilot Demo Day webinar from the Track and Know project healthcare service, using patient mobility information to understand the provision of services across large rural and urban communities. I'm Jenny Rainbird, a project manager from Inlicom Systems, who are the coordinators of the Track and Know project. Before we start, I would like to provide some general information. The webinar is in listen-only mode. We invite you to pose questions using the chat box, which we will answer in the Q&A session at the end. The webinar will be recorded, and both the slides and the webinar will be available via the Track and Know website in a few days. Here's an overview of our agenda for today. To enable us to understand our audience, we would like to kick off with a short audience poll. I will then give an overview of the Big Data webinar series and an introduction to today's speakers. Marios Logothesis from Intrasoft will give an introduction to the Track and Know approach and architecture. Then Dr. Tony Strakova from Cambridge Medical will present the requirements of the healthcare pilot, after which Kieran Lee from the Royal Papworth Hospital and Livio Bruvella from the University of Zurich will deliver a demonstration. We will then have a Q&A session before Marique Williams and Despina Kopanaki, the organisers, close this webinar series. Our poll today is 5 short questions, as I said, to understand our audience and their interest areas. The questions are multiple choice and include the following. Which stakeholder group do you belong to? Are you working in the healthcare service industry? Are you working with big data? Are you interested in big data technologies to optimize your customer experience? And what is the main barrier or risk preventing you from implementing big data analytical solutions in your organizations? I will now launch the poll and give you a minute or two to respond. Thank you. I can see from the poll that a number of our attendees are from research and academia. We have some big data providers and some technology providers on the call. 25% of the audience are working in the healthcare service industry and 60% are working with big data. The vast majority are interested in big data technologies to optimize the customer experience, and the predominant barrier to implementing big data seems to be lack of expertise and uncertain value. Thank you for participating in the poll. So to give you an overview, driven by Big Data Stack and the IBIDAS project, a number of the Big Data Value PPP research projects have come together to form an initiative to deliver a series of webinars under a common theme of big data research demonstrators. All the projects are aimed at addressing the growing need for big data technologies to unlock the potential in various application domains. IBIDAS, Big Data Stack and Track and Know and the Policy Cloud project are developing innovative technologies to address the emerging needs of data operations and applications, and are using pilots to demonstrate the sustainability and applicability of their solutions in a wide variety of sectors. As IBIDAS, Big Data Stack and Track and Know reach their final year, They are ready to demonstrate the developed and implemented technologies to interested end users from industry, as well as technology providers for further adoption. In addition, the newly initiated Policy Cloud project highlights the adoption of technologies developed by Big Data Stack and showcasing their application in the policy-making sector. These are the 4 BVA PPP projects which are joining forces to showcase the application of innovative technologies and foster further adoption, contributing to Europe's digital future. Big Data Stack are developing a holistic stack for big data applications and operations. IBIDAS is researching industrial-driven big data and self-service solutions. Track and Know is focusing on big data for mobility tracking and knowledge extraction in urban areas. And Policy Cloud is developing cloud technologies for data-driven policy management. This webinar from Track and Know on healthcare using patient mobility information to understand the provision of services across large rural and urban communities is the last in the series of webinars, which has covered areas including the financial sector, shipping, policy, communication data, telecommunications, and manufacturing. All of the webinars are or will shortly be available via the BDVA PPP and on each project's website. Today's speakers are Marios Logothesis from Intrasoft. Marios is a senior researcher and innovation manager whose interests include the identification of application areas and commercialization models where new emerging technologies such as big data analytics, Internet of Things, and blockchain provide a positive impact. Marios is the Track and Know platform integration lead and will give an introduction to the Track and Know approach and architecture. Kieran Lee from the Royal Papworth Hospital is a psychology graduate from the University of Stirling, where he has a background in neuroimaging, behavioural and animal behaviour research. He joined Royal Papworth Hospital in 2017 and now works as a research practitioner with the R&D team. His work involves contributing to projects primarily focusing on improving the sleep service, accessibility and efficiency. Kieran has been managing the day-to-day workload of the Track and Know project pilot in healthcare service optimization for the last 2 years and has facilitated the development of various collaborative partnerships over the course of the project. Livio Bruvella is an MSc student in Geographical Information Science at the University of Zurich. He is currently working on his master's thesis on the topic of car accident risk prediction using GPS trajectories. Livio has been working on the implementation and interactive visualization for the Track and Know healthcare service optimization pilot. And Dr. Toni Strakova is the director at the Cambridge Medical Academy. She is a specialist physician and geriatrician who has been actively involved in the clinical innovation projects in Cambridge and across the EU over the last 10 years. It is now my pleasure to hand over to Marios Logothesis from Intrasoft for an introduction to the Track and Know approach and architecture. Marios, the floor is yours.
Thank you, Jenny. Let me share my screen. I hope you all see now my screen. First of all, thank you all for attending this workshop. I'm Marios Logothetis from Intrasoft International. I'm working at R&D department as a senior innovation and research manager. And I have a few slides about the approach and the architecture that we had during the Track and Know project. So before starting with the description of the approach, I would like just to mention some of the challenges and the businesses that we have identified during, let's say, the first design of the platform. So the first one was that we identify a shift in the software development ecosystem, meaning that now from a complex coding, we find that we have to create, to design and develop software solutions that are going to handle large amounts of data. So as we call it, big data. So this was one of the challenges that we identified, and also having in mind what is the terminology of the big data, we were able to design a data streaming and analytics platform where we actually decouple the complexity of the data sources from the databases and the data processing algorithms. So we built a data streaming platform where some of the characteristics was that it was real-time monitoring and device processing. We were talking about the distributed message system platform. And one of the two, let's say, main characteristics was also that it was high scalable and with a high fault tolerance. So this is a detail, I could say, architecture of the Tracking platform. First of all, I would say that at the middle where you see it's the data management solution, which actually was the Tracking platform. And with that platform, which is based on open source and Kafka technologies, we were able to ingest large amount of data coming from different data sources. And when I say different data sources, could be any data stream coming from an IoT device, or could be also a connector with batch data or databases in general. So for different data sources, we will be able to create some connectors in order to ingest those data to our streaming core platform. Just to mention, our streaming core platform, as I told you, was a distributed platform. So we were able to create 16 virtual machines in order to handle those large data. And at the right side, you can see that where actually there are the data analytics part and the visualization part, where the other presenters are going to present next what they have done. Just to sum up with the platform, just some of the characteristics. As I told you, it was a distributed streaming platform for handling and ingesting real-time data. It was based on the Apache Kafka, which is an open source. And some of the major key capabilities of the platform was, again, that it was real time. We were able to, in real time, monitor any type of event. It was able to interoperate with all modern data storage technologies. And of course, one of, let's say, major here characteristics was that the security. So we were able to develop and some of the mechanisms in order to achieve the encryption, authentication, and the authorization. Apart from that, what we also identify is that we were able to use that type of platform in order to automate the end-to-end life cycle of the machine learning applications. And when we say continuous delivery of the machine learning, we have in mind three specific things. The first one, that we were able, with that ingestion of the data and actually forwarding the data to processing infrastructure as the Hadoop cluster, we were able to model train and to validate the models. Then we were able, with this platform, to inference the model or in the edge or in the cloud, depending where we would like to execute an ML application. And the third one was that with that platform, we were able to monitor real-time the model, and with specific KPIs to have alerts and to improve, again, the machine learning based on specific outcomes of the machine learning model. So As I already told you, this is a system architecture at the right, and that's what we had implemented during the tracking project. As I told you, we have deployed that platform in 16 virtual machines. And just as a final slide from my presentation was where we think that this type of platform can also can also support other use cases apart from those that we were dealing in tracking now. The first one, as I already told you, and we are again using that, is for real-time monitoring and in general collecting any type of metrics and alerts. Some examples of the industry that are using for that purpose, you can see is Netflix or an Airbnb. The second use case, which is actually where it all happened with the Kafka and started, was by LinkedIn, where actually introduced Kafka to the industry, and the main purpose was to create message queues in the content feeds and a typical public subscribe system. Another use case is the analytics and any real-time X functionality that you can have, for example, processing or visualization. And last but not least, such type of platforms can facilitate the distributed data center and the distributed log system. Thank you very much for this. And Jenny, please. I pass the floor to you to continue with the other presenters. Thank you so much.
Thank you, Marios, for that overview of the Tracano approach and architecture. I would now like to hand over to Dr. Tony Strakova from the Cambridge Medical Academy to present the requirements of the healthcare pilot. Tony, the floor is yours. Thank you.
Thank you very much, Jenny, for the introduction, and Marius for your presentation. Can you see my slides? Full screen?
Yes, we can now.
Okay,
thank you.
Here we go. Okay. Today, we will give you an overview of the healthcare pilot from several perspectives. I will briefly outline what the main business case in the health pilot is about, the business questions, which you can see here, and which tools from the Track and Know toolbox are deployed to answer the questions. Following that, Kieran will show you the user perspective, which is how the user questions were answered and what are the conclusions for the service. And then we will move to showing you what's the most important for our users, the dashboard. So at the end, we also want to spend a few minutes showing you the progress in the second business case, which is about setting up experiments to try and derive a driving profile of sleep-deprived drivers in order to develop future tools for risk of crash and identification. So the main case of the health pilot is about optimization of a service which delivers care in facilities distributed across a geographical area, and we suspect inefficiencies which we cannot currently identify with the existing business intelligence tools. So allow me to say a few words about the main partners in the health pilot. The business case comes from Royal Papworth Hospital, which is a specialized world-class hospital with 310 beds, which moved last year to its new site in Cambridge, treating heart, lung, and sleep disorders. The clinical lead of the health pilot is Dr. Ian Smith, who is the director of the sleep services, as well as director of R&D. And you can see Ian here on a nice GDPR compliant photo with Her Majesty the Queen at the opening of the new hospital. Ian brought the healthcare business case to the Track and Know project, and his concept, how to deploy big data tools for real life problems in healthcare, has already made headlines, as you can see. Now, a few words about the condition and the center of the sleep service. Obstructive sleep apnea, or OSA, as we abbreviate it, is the breathing disorder which occurs during sleep, where sufferers have frequent episodes of stopping breathing at night or when they sleep. If the condition is left undiagnosed and untreated, it raises the risk of serious health problems, death, as well as motor vehicle collisions due to the sleep deprivation and the sleepiness on the wheel. So the incidence is very high, and in some areas, the health services are totally overwhelmed with waiting lists for tests and consultations. So Papua's sleep services cover the region with 21 facilities distributed across Cambridgeshire. The optimal positioning of these facilities to meet the real demand is the center of the health pilot research. Here you can see the facilities. In Track and Know, Papua's team is supported by my organization, Cambridge Medical Academy. We provide the necessary know-how for the collaboration between real users in healthcare who have not been exposed to system development processes with technology partners, and the technology partners who have to understand the user's needs. So our work ensures that the system is designed to solve the healthcare's real-life problems. But beyond the project, my organization's core business is to enable collaborations between healthcare professionals at national and international level to share knowledge, training, work, and research. Other important partners who have helped us very much in this technical design are partner Indicom, the coordinator, and University of Zurich, who have been heavily involved in the technical work related to optimization. Also partner Fraunhofer for visual analytics, University of Piraeus for the enrichment of the data, and Democritus for the complex event recognition. Here you can see our website of our platform. Now back to the business case of the health pilot, business case 1. What are the problems that the pilot seeks to solve with the big data tools? So in spite of the presence of those 21 facilities, the service seems to be ineffective, and we have no tools to investigate this. So the problem is that the hospital IT systems are not geared to provide answers to our questions, which are, for example, how come patients are booked so that they often travel longer distances and often drive past a nearby clinic in order to get to a more distant center? Is the long distance a factor which plays a role for the high no-show rates? Where is the highest demand? That means, what is the geographical distribution of patients with high risk for OSA? And are the clinics really positioned there to match the demand? Are we using our resource efficiently? And by how much can we reduce the appointment travel if we optimize the clinic positions and allocations? And what impact would that have on the CO2 emissions? To address these questions, the health pilot uses a variety of data types and sources, which would normally not be possible to analyze together in context using existing tools. So in order to design for Track and Know to design the necessary pipeline of tools, Papua has provided large appointment data sets from its booking system, which contain various spatial data, temporal data, as well as data about the actual appointments. There is also a medical data set, appropriately de-identified and protected for some offline subgroup analysis to answer certain research questions. Then this is combined with open data, which provide information that allows analysis of risk distribution, which you will see in the demo why this matters. In addition, there's weather data that allow analysis about factors for non-attendance, point of interest data, allowing new insights about potential positioning of facilities, or even considerations of using other, like third parties' locations. So the pilot is also interested in collecting driving data from GPS and accelerometers for two reasons. One reason is to validate the assumptions about the patient travel made in the business case. And the second reason is to investigate the driving behavior. So the collection of patient travel data had to be abandoned, though, during the COVID crisis, and we had to slightly rearrange the driving study to studying shift workers as opposed to sleepy patients in order to derive our sleepy profiles, and you will hear a little bit about it at the end. Here you will see the data properties. The larger data set contains 4.5 years of data, 46,000 journeys, which translate to 17 million messages inside the TK track and nose system. This schema briefly shows you that the large data set contains subsets of different clinic constellations. So here are the clinics, and so this batch shows one set of clinic, this batch shows another set of clinics. And what we are doing is we are giving this data set allows us enough versions that we can try and compare the different layouts with the real life data. So after the COVID recovery, we will be able to add more data to our comparisons. At the moment, we're working with historical data sets due to the situation. So here is a very brief overview of the users, requirements, and the KPIs. The users of the system will be mainly in the first line, the business intelligence and operation managers who need analytics, insights, and who need to have decision support, what to do with the service. And following that, the booking clerks who manage the appointments and allocate the patients to different clinics will be able to use the same system. The business requirements are the system should be able to capture the service operations across a geographical area over a given period. They evaluate the service demand from multiple data sources, to run simulation scenarios and select the most effective service, to test the proposed model in a pilot, and to validate the trajectories with real data. The functional requirements are that the system should be able to do online analysis of heterogeneous data sources and provide us with automated business intelligence on patterns of service use versus patterns of demand, to enable simulations and measure KPIs of optimal service operations, and offline the system has a lot of tasks to provide visual analytics, complex event recognitions for identification of factors which affect the service, as well as new solutions. The KPIs are reduction of travel we want to achieve, cost efficiency gains, reduction of the no-show rate, and reduction of CO2 emissions. Now we're coming to a slightly busy slide which shows the technical overview of the TK pipeline. The pipeline starts with the input of raw data into the BDP toolbox, and as a first step produces from the appointment data reconstruction of journeys. You will see a slide later on with more details on the reconstruction presented by Kieran. From here, there are then two main parts. The reconstructed journeys go to the BDA toolbox and undergo a p-median analysis to identify the optimal allocation of clinic to patient reaching the KPI1 reduction of travel. The p-median analysis uses a genetic p-median algorithm and is currently in the process of being completed. The output of this that can be viewed directly in the dashboard, which you will see in the demo. But what is of higher value is the ability of the system to combine allocation suggestions with demand maps that are created from various angles, demand based on real patient data collection, census data, risk data. So various sources give different points of view. And the results enable the measurement of KPIs, distance reduction, cost efficiency gains, and CO2 reduction as derived values. Going back to the other path and the reconstructed journeys, in the BDP toolbox, they undergo weather enrichment and POI enrichment. The analysis of the results then allows further insights about factors affecting the service and decisions on options to explore. So the service has a number of questions which require also offline visual analytics and complex event recognition. And we'll show you some examples, especially what we found for KPI 3 no-show rates. The insights from those analytics then enable further decision-making as to what to send to post-processing for repeat p-median analysis. I will not go into the expanded view. I think this is enough for now. Briefly mentioning the market situation before passing on to Kieran. There isn't a lot on the market that does what we are trying to do. In fact, there is nothing that does exactly what we're trying to do. There are a few publications using the location allocation method to be deployed by Tracker now in healthcare, which matches supply, demand, and optimal distances. But the tools are being used in other business domain, for example, allocation of police stations. There are also scheduling methods which are using geographical locations to schedule patients, but this is mostly in the US, and their business cases are somewhat different because they're driven by insurances, and this is quite different from the NHS. In the UK, domains which use scheduling and geographically supported scheduling are emergency response and also public health systems. Now, one word about COVID-19. COVID made the situation worse. The NHS waiting lists are now huge. It's expected to hit 10 million this year. And this makes our job even more important because the NHS guidance documents now clearly say, please replan the services, use other third-party facilities, try to redistribute the patients, pay attention to the geospatial context. So COVID has actually made us really bring even more value to the system. So our unique value proposition is that we're bringing novel business intelligence on demand and supply. Our simulation allows what-if scenarios, and also the tool can be used for operational purposes, not just for simulation. And with this, I would like to pass on to Kieran Lee, who will talk about the results that we find important. It will not be all results. Kieran, the floor is yours.
Hello, everyone. Thank you, Tony. Yeah, my name's Kieran. I'm a research practitioner at Royal Patworth Hospital, and I'm going to talk to you a little bit about the data used in this business case of the pilot and some of the early offline results that we got. So the data is 5 years worth of patient bookings into this OSA diagnostic testing network that was shown earlier. This equated to a little over 46,000 planned pickups and just under 24,000 patients. And we took the patient's home address, translated that into GPS coordinates, and then reconstructed the most likely journey between those coordinates and the facility that the patient went to pick up the test. And then we used this data for the business case. And on top of using the real life patient data, we're also incorporating open source data, which looks at the population distribution over East Anglia, the impact of alternative sleep centres in East Anglia, which might take away some of the demand for Papworth's service in certain areas, and also the geographical spread of OSA risk. As we know, the risk factors related to OSA, things such as diabetes, hypertension, smoking, alcohol intake, is not uniform over the catchment area, and there are sort of hotspots of high risk and areas that are of less risk. And so this was the first sort of result that we got in the project, which was just simply mapping the patients onto the catchment and looking at that in context of the exchange facility network. And what we can see are there are large clusters of patients in areas that match high population areas. So we've got a lot of patients in Cambridge, in Bedford, and in Peterborough. And there are also exchange facilities located in quite close proximity to a lot of these clusters. So the network isn't completely terrible. It is hitting some of the places it needs to do. But saying that, there are also some other spots which are not well serviced. For instance, Kings Lynn up here, there's a network that's not well serviced, and Bishop Stortford down here, again, there's another large cluster with not many patients. And some of the rural areas are not very well serviced. And then looking at the journeys that the patients have taken from their residence to the exchange facility, we found that the average journey was almost 33 kilometers. And that journey is being done 4 times when a patient has to collect the test, take it home, wear the device overnight to record the sleep data, and then drop it off again the next day. We also found that a lot of patients aren't actually coming to the closest facility and are actually driving past it to get to the hospital. So you can see in this figure here, you've got patients sort of on the coast who are traveling more than 100 kilometers to get access to these tests, even though there are clinic sites located closer to them. And if everybody was booked into the nearest facility, we could drop the mean travel distance by almost a half. And surprisingly, there was no relationship between travel distance taken to get access to a test and the no-show rate. So this was looking at the data in a different way. It's a flow of the patient traffic and no-shows across the catchment. The thickness of the line represents the amount of patients coming from one geographical area to that particular exchange facility, and the color of the line represents no-show ratio. So the darker the line, the higher number of patients no-showing. And this clearly shows you've got lots of patients all around the catchment flowing into Patworth, despite having this network with other facilities available. And again, just looking at the no-show data. So this figure displays every exchange facility and the average distance traveled to those facilities for both the patients attending their appointment and those who didn't attend their appointment. And we see the highest mean travel distance is at the hospital itself, and the rest are a little bit less. But for every facility, there is no difference between the show and the no-show rate for travel distance. So that was the early sort of offline data that we looked at in this business case. I'm now going to hand over to Livio at the University of Zurich to give you a demonstration of the dashboard that's been developed.
Thank you, Kieran. Livio, you can go ahead with your presentation.
Hello, everyone. The next part will be a short demonstration. We are currently working on a dashboard, which allows to interactively visualize the optimal distribution of these oximeter pickup facilities. Let me share my screen. Okay, so I will now show you some of the current functionality of this. This is still work in progress, so feel free to make any suggestions later. This is the first clip.
I think your sound of the video is not on. Can you push the sound thing on the right-hand side?
Yes, wait a second. Oh yes, share computer sound.
We, as a user, access this simulation tool to view results.
I'm currently running it in a browser. You're currently running it in full screen, but if I go out of full screen, you see I'm just in regular Google Chrome, and the service can be hosted on the web server and accessed by that. Okay, so this was the first clip. I'm just showing us how to access this dashboard. Basically, it can be run in any web browser since it's just a web page. The next clip would show how we compare the current layout of the facilities versus the optimal layout of these oximeter pickup facilities.
Can we see the current service being offered by Patworth compared to the optimal service for the current patients that would reduce the average travel distance?
Yes, we can, for example, look at the hospital or the patient demand, and we can look at our current facilities, for example, the new Patworth Hospital, and we can compare this with the optimal facility distribution, which would look like this, and we can see how the travel distance changes depending on how many optimal facilities we place. And then the next clip would show us how we can rearrange this facility network according to the risk factor of the OSA risk.
We would rearrange the network based on obstructive sleep apnea risk as opposed to just current patients using the service?
Yes, we can change between different demand scenarios. This would be the risk demand, where we look at the location of patients depending on the risk level. We can also show this risk score on a map. This risk score is calculated from obesity and age. And we can see if we change this to the risk factor demand, the facilities are distributed so that the areas with a high risk factor are well serviced. Then our next clip shows us how we can use different type of risk maps to underline our optimal facility distribution.
Between different risk maps, please, and how does that help us?
For example, we can compare the distribution of the optimal facilities between the risk factor and the census demand, where the census demand is calculated through the population density. The risk factor is calculated through the already mentioned risk score containing obesity and age. And we can see that if we change it to the census demand, the location of the facilities slightly changes, so that the areas with high population density are better serviced compared to the risk factor scenario.
So this then enables the operations manager to decide which factors are more important for them.
Yes, they can decide what is most important to them, if it's the population density, or if it's the location of existing patients, or if it's the risk factor of a certain location. This allows them to decide on which factors they should optimize their service. Then the next clip shows us again how we can compare different facility and risk scenarios with the current one and the optimal one.
Right-hand side, the green facilities, which are the optimal calculated facilities closest to the patients at the number of 18 facilities. Can you please show us now how do these ones compare to the current facilities that the service operates in that region?
Okay, we can click here on the current facilities, and then we can see the current facilities on the same map, or we can look at them on a different map, which is, you need to select the same scenario, which we already have here. So we can either look here, see the current layout, or we can look at the current layout on a different map if you want to compare it side by side.
Okay. Here we
And then the next clip is about deciding if you want to make the network of the facility smaller or larger. How do we best add new facilities?
Scale back the outreach network and maybe cut 5 clinics out of the current scenario. And would you be able to tell me what would be the best 5 clinics to remove to keep accessibility at a high level to patients? And then after that, also the alternative, if I was looking to invest in the network and maybe add 5 facilities, where perhaps the best 5 locations would be to add them.
Okay, let's look first what happens if we reduce the current network of facilities by 5. So currently, with this scenario, we have 27 current facilities, and we can look at what would happen if we redistribute them and to 22 facilities. And we can see if we redistribute these facilities to 22, then we get an average weighted travel distance of 11.2 kilometers, which is still far lower than the current weighted travel distance of 18.9 kilometers using 5 more facilities. On the other hand, if you want to see, if you want to add new facilities, we can select the conditional p-median scenario, which shows us where to best put our new additional facilities. So we can see if you want to put 1 additional facility for this scenario, it will put it on the bottom left, and it would already reduce the travel distance by more than 2.5 kilometers. And if we add more, we can see the travel distance further decreases, but after some point it doesn't decrease that much anymore. Okay, and so in the last clip, we can again compare different demand scenarios or different risk maps side by side.
a 3-part question. What is the current optimal facility number and distance for the current set of patients? Then what is it based on the risk scores distribution across the area? And then what is it based on the census population data? How can we work out the differences?
Okay. We can first look at the optimal distribution according to the current patient's location, and we can compare this with a map of the density of patients. So we can see that the facilities are distributed more according to the distribution of the patients, and we can compare this with the optimal distribution of the risk factor. We see it changes a lot because the distribution of the risk factor is quite different than the distribution of the patient's density. And we can also look at the optimal distribution according to the population density, the census demand scenario. And with this scenario, we can here look at the population density, and again we can see the service layout is optimized so that areas with high population density are well serviced.
Perfect. Thanks.
Okay, so in summary, this dashboard will allow us to easily compare different demand scenarios and facility layouts, and obviously this idea could be applied to different allocations problems. This is not only suitable for oximeter pickup facilities, and yes, this would be the end of this short demonstration part, and now let's head back to Kieran.
Thank you very much, Livia. This is amazing work. Congratulations, and it's going to be very useful for us. Kieran, in the interest of time, I would like to ask you to summarize briefly the results so far of the Health Pilot Business Case 1, and just give it maybe a couple of minutes max to mention the driving pilot, which is very interesting, but obviously we have to conclude the seminar on time, so please go ahead.
Hi, yes, of course. So what you've seen there is that the dashboard clearly has a lot of features and a lot of ways of sort of looking at the data from different perspectives. But what that means for us at the hospital is that we can look at our network, we can see where our current facilities are, and we can see where the optimal location of those facilities should be to make accessibility as easy as possible. So from this map, you can see that there are some sites really well located, so these should remain open. But we also have some areas that are not so well located. So the sort of core and eastern area maybe have too many facilities, and the northern area is a little bit underserviced. So we know how to redistribute this now to make things easier for our patients. And then, so just finally, the next steps that we're sort of looking at with this business case is digging into this risk map of OSA risk over the catchment area and the need for our service. So at the moment, we do have a risk map, but it's quite simplistic. It's just looking at two risk factors of OSA, age and obesity. But we know from previous research there's lots of other factors that go into this, such as having hypertension and diabetes. And so we're working with the University of Bedfordshire to come up with a model that can incorporate all of these risks, and we can apply appropriate weightings to each risk to really get a nice, accurate map showing the geographical spread of OSA risk. And then we will incorporate this new enhanced map into our modeling in. Yeah, so hopefully that's given you a really good idea of the first business case in pilot 2 of Track and Know. You've seen the problems that we have and how this technology is being used to address those problems. But on top of that, we also have a second business case, which is a lot less mature than the first one, but is nevertheless a sort of exciting prospect for us. This is going to look at our shift workers at the hospital, as we know that that shift workers are at a higher risk of having a motor vehicle collision than a regular driver. And this is a bit of a worry due to the large number of shift workers at the hospital. So within this project, we're going to track the driving behavior of those shift workers and then compare data from when they drove in for a night shift versus a day shift, and also just generally shift workers compared to non-shift workers, to see if we can sort of unravel some of the mysteries in this problem. Yeah, that's all I can really say on that for time today. But keep watching this space, and hopefully we'll have some exciting results in the future for you.
Thank you, Kieran. I think we're whetting up the appetite for everybody to come to our next webinar, where we will talk about driving study. Thank you so much, and back to Jenny to continue with the conclusion.
Thank you. Thank you so much, and we're really sorry that we haven't had a chance to look at everything we wanted to show you today in full detail. We wanted to leave a little bit of time just to look at some of the questions that you've asked us, and also to close the webinar with our organisers. So we'll just give us a couple of these questions and have a look if we can answer some of these, and some of them we may have to get back to you. So I'll go straight through. Question number 1, why have you decided to incorporate census and condition risk data into your modelling? Would it not be best to simply make the service more accessible for patients currently using it?
Hi, yeah, I could probably take that one. So although the hospital does clearly have a duty to make the service better for its current patients, it's important to note that when we built this outreach network, that was built on opportunity, and it wasn't really a data-driven process. So it is likely that wasn't, well, we've showed it wasn't built in the most efficient way, and there are hotspots of patients in need of a service that aren't currently getting access to that service. So we have a duty to make the service better for those patients, for a couple of reasons. One would be it would improve the well-being and quality of life of that patient. And the second one would be, if we can diagnose and treat these people, it actually reduces costs for the NHS in other areas of healthcare, such as having less need to go to a cardiovascular clinic.
Thank you, Kieran. That's great. On to the next question then. How is Tracano applicable to other healthcare services, and is it scalable and transferable?
I think I should take that. Yes, it is very much applicable to most healthcare services. Our research has shown that every hospital has at least 5 services that practice geographically distributed care for various reasons, whether it's diabetes clinics or psychiatry. There are many clinics that have the same issue, and especially now with COVID is going to be even more applicable. So yes, it is applicable to all of the services across the UK. Our plan is to have a success story to implement it in several hospitals at the NHS first before we go European and scale it up, but we've already attracted interest, and it is also transferable to similar domains, for example, more like social care, home care, that are not necessarily just NHS but are outside the NHS, have distributed services. We think we've really got something we've stumbled upon a very interesting business case with wide applicability thanks to Papua's suggestion and concept.
Thank you, Tony. I think we'll just take one more before I hand over. So what is the next step for your pilot towards implementation in real life?
We've already started working on our exploitation at UK level. We are at the moment working with data across several services within a UK-based, Innovate-based UK-based project, which shows various options how this could be deployed on a UK cloud. The initial part of the service will be about remote web-based access for operations managers, and once this is successful, then we will be negotiating implementation in the NHS systems for the booking clerks. The simulations don't have to be in the NHS system, but the booking clerks need to operate within. So it's a 2-step implementation, and we've already taken some steps.
Thank you, Tony. And thank you to all our speakers today and for the very interesting webinar. Unfortunately, we can't answer all your questions, but please contact us via the Tracano website if you would like to get in touch with us. I'd now like to hand over to the webinar series organisers, Marieke Williams and Despina Kopaniaki, to close the series. Thank you.
Hi, Jenny, and let me start sharing my screen. So I hope it's visible now.
Yes, thank you.
Great. So thank you, Jenny, for the invitation to both me, Marieke Williams, and Despina Kopaniaki for this final webinar in the series. Just a quick introduction of myself. I'm Marieke Williams from Trust IT. I'm project manager for several projects there, and today I speak with two hats on, the first one of Big Data Stack and the second of Policy Cloud, where I lead the communication and dissemination in both big data projects. So this presentation is really very quickly to finalize this and to kind of round up what we've done in these past already 2 months. So let me pass to the next slide. So as you already introduced in the beginning of this webinar, this is really a series of big data pilot demo days where 4 projects have joined forces. This is a quick overview of what we've been showing in these 2 months in these 9 webinars. The aim was to demonstrate the added value of big data technologies and their application in a wide variety of domains. So for today, for example, we saw the healthcare service, but we've also seen retail, we've seen the financial sector, telecommunications, even manufacturing, and even on to policy making levels. So the aim was to demonstrate that with the purpose of fostering further adoption of these technologies and to engage with a wide scope of stakeholders at the virtual BDV PPP Summit 2020 that really supported us in the whole series, that really provided us this connection with their audience and really gave us the visibility that we needed for this series. This also produced reusable outputs that today are very useful for each of these projects to demonstrate to possible end users and potential adopters to understand what the added value of these technologies are. And then in the end, obviously, finally, we contribute to Europe's digital future. So this is a quick overview of what the titles of these webinars are and their content. So a few numbers, because I mean, 9 webinars, we say it quickly, but it's not that quickly done. So we want to really give a big thank you to all involved and all attended. So there were 4 projects, 9 webinars, and 9 demonstrations of innovative big data technologies in 9 different domains. And we had over 420 attendees, and plus all of you that are engaging with us in this demonstration today. So we're reaching the 480 attendees. So a big thank you to all involved in that. We couldn't have done it without you. So let me try and get to the next slide. So there are some, we've asked some of the people involved and some of the people that have been attending our webinars for some insights. So this is Joseph Moatri, from IBM Research and Big Data Stack Coordinator. And he says that the Big Data Pilot Demo Day series has provided Big Data Stack with valuable reusable demos that show the added value of working of our technologies even beyond the applications of our pilot use cases. So specifically, a project consortium has reused the demo recordings to understand how to adopt and enhance the Big Data Stack technologies in their project proposal. Now, for the next insights and more about the series, I would like to pass the floor on to Despina Kopaniaki. Despina, can you please present yourself and finalize this great adventure together?
Thank you, Marieke. Many thanks. Many thanks, Jenny, for the invitation. So my name is Despina Kopaniaki. I'm project manager at Forth and a member of the IBDAS coordination team. So for IBIDAS, the Big Data Pilot Demo Days turned out to be a valuable and worth to remember collaboration. We started in March, 2 projects, Big Data Stack and IBIDAS, brainstorming and trying to find new ways to collaborate under these circumstances. So we began to design the webinars, and then Track and Know and Policy Cloud accepted our invitation and joined us, resulting in a series of 9 webinars in 9 application domains, demonstrating the innovative big data technologies developed. So, as Professor Sortiris Ioannidis, who is the IBIDAS project coordinator, said, this series of webinars has brought us closer to our ultimate goal of breaking intra and inter-domain data silos and data sharing. This would not have been possible without the close collaboration of all big data PPP projects. When we asked Nuria Delama from Atos Board of Directors in Big Data Value Association and also IBIDAS External Advisory Board member, she said that the Big Data Pilot Demo Day series has proved to be a very useful tool to showcase the results of the PPP projects. It is a window to discover how big data solutions can help to solve real problems in multiple industries. So on behalf of the IBIDAS Consortium, we would like to thank the Big Data Value Association for giving us the opportunity to organize the series of webinars under the virtual Big Data Value PPP Summit 2020. Big Data Stack, Track and Know, and Policy Cloud for their excellent collaboration. Special thanks to Trust IT for making this happen by offering the tools, Andrea and Diego for their continued support. Special thanks to Marik for this close collaboration. I felt that we were working together for many years. Special thanks to all the webinar speakers for their engaging talks. And last but not least, we would like to thank all the attendees for joining us in this journey. So, all the webinar recordings are available on our project websites, YouTube channels, BDVA website. In case you have missed some, you can visit again and see them. Here you can see the QR codes that they redirect you to each project webinars. A concluded report will be produced on the joint effort of the series, the stakeholders engaged, and the reusable outputs. The Big Data Pilot Demo Days recordings are a valuable output of the series to be used by all interested to understand how the big data technologies presented can add value to your project and organization. So that's all from me. A big thank you from IBIDAS also. Marika, you want to add something? Jenny, the floor is yours.
Thank you. No, I think that was a really positive note to end this webinar series. And thank you again for inviting us and for organising. And thank you to all the people who joined us today. Thank you very much.
Thank you.
Thank you and goodbye. Thank you.
Thank you. Bye.